Marina Coastal Water District is trying to put together an accurate model of the distribution of freshwater and saltwater in the subsurface. They're also trying to put together an accurate model of the distribution of the various sediment types in the subsurface. Where is there sand and gravel? Where is there clay? Because sediment type controls the movement of saltwater and freshwater through that area.
The district currently is 100% dependent on groundwater today, and we project even in the future groundwater is going to play a critical role in serving our customers. So we are very interested in ensuring that that water is sustainable today and in the future. And so that requires that we get as much information as we can.
So in their attempts to build these models, they have very limited data. They have well data, but well data only samples directly beneath where that well is located, and many of the wells in that area don't go very deep. So the objective of the Skycam survey is to acquire geophysical data that allows them to image over a large area to a depth of about 1,000 feet below the ground surface, mapping out how sediment type is varying. Well, clays are much more electrically conductive than sand. And so if we see an electrically conductive unit, we would interpret it as the presence of more clay in that area. They're also interested in mapping out the distribution of saltwater and freshwater. Saltwater is much more electrically conductive than freshwater. And so if we see a conductive signature in an area, we could attribute that to saltwater. And this is basic information that they need to build models to help them better understand how to effectively manage their groundwater resources, and they also have a particular interest at this moment in time in understanding the potential impact of a proposed desalination operation on their groundwater resources. Partnering with us in this study is Aqua Geo Frameworks. They've been acquiring Skycam data in other states for the past few years, so having them as partners on this is a really important part of ensuring our success. The starting point when we talk about the Skycam system is a large transmitter loop that hangs beneath the helicopter. And through that loop, current is sent. By sending current through that loop, you generate a magnetic field.
That magnetic field goes in the ground, it gets converted to current, the current flows through the ground, and we measure where the current goes.
Those currents are really what are sampling the electrical conductivity of the subsurface, and those currents then generate a secondary magnetic field that is recorded by an instrument also carried beneath the helicopter.
This is going to provide us good information, especially since we're able to take what is provided here and ground truth it with other information.
So what we've been working on over the last few years is to use a different geophysical method where instead of using a magnetic field to induce current flow, you actually inject current into the subsurface. And the method we used was called electrical resistivity tomography. So in that study, we moved along the Monterey Beach, putting electrodes every 22.5 meters and getting current into the subsurface and mapping out the change in the electrical properties of the subsurface down to a depth of about 1,000 feet. Well, that gave us a slice just right below your feet as you walk along the beach. We could see to a depth of 1,000 feet, but it was one 25-mile long slice. Well, now what we want to do is to be able to move farther inland.
We found out that we didn't have to just put isolated points to get the ERT, that we could put instrumentation on a helicopter and fly an area and really get a 3D image. That was really attractive to the district to understand that that was available.
The ERT survey will serve as an amazing check, first of all, to see whether our values are lining up with what we originally collected with the ERT system in 2014. We can see what the difference is, how the system has changed from 2014 to 2017, how much salt water has come in or moved out of the system based on different pumping and based on how much groundwater management and recharge has gone on in the area.
When we acquired the data along the coastline, it took us about a week and a half to acquire 25 miles of data. In this Skycam survey, we're going to be collecting 375 miles of data in a few days. So this is just an incredible opportunity to get a tremendous data set.
What we're moving toward is trying to play a zero-sum game where the water in equals the water out, so that we're not continually depleting our water resources. In order to do that, we need to characterize the region with a high degree of certainty and spatial continuity, and that's what this system offers.
A real enthusiasm of mine is getting broader adoption of geophysical methods for groundwater management. So we are absolutely thrilled to be involved with Marina Coastal Water District in this project, and it's just very enlightened of them to think about using geophysical methods to improve their groundwater model.